Hi everyone, welcome back to my channel. Today we are going to solve an important previous year questions from surface chemistry. If you are preparing for CSIR NET, GATE or BARC, this concept is extremely important. Let's see the question. This question has asked in CSIR NET December 2018 Part B 2 mark question. See the question. The internal pressure of liquid drop is greater than the external pressure by 1.5 into 10 to the power 5 Newton per meter square. The surface tension of the liquid is closest to. Here radius is given as 10 to the power minus 6 meter. So they have asked surface tension and option is given as 150, 125, 100 and 75. So here key concept used liquid drop model. For we'll see the formula for liquid drop model. Delta P is equal to 2 into gamma divided by R. For soap bubble, delta P is equal to 4 gamma divided by R, where delta P is equal to P inside minus P outside is equal to excess pressure. In question they have given the internal pressure of liquid drop is greater than the external pressure by 1.5 into 10 to the power 5 Newton per meter square. This means delta P is equal to P inside minus P outside is equal to 1.5 into 10 to the power 5. The difference is called excess pressure delta P, and gamma is equal to surface tension and R is equal to radius. Here they have asked liquid drop. So delta P is equal to 2 into gamma divided by R. This formula will be going to use. So this soap bubble formula in this particular question no need to use, but remember this formula. We'll see what it has given. Radius has given R is equal to 1 into 10 to the power minus 6 meter, and also excess pressure is given. Delta P is equal to 1.5 into 10 to the power 5 Newton per meter square. Here we have to find surface tension gamma. The unit should be meter into Newton per meter. So this is step 1. We have to find liquid formula. That formula will be delta P is equal to 2 into gamma divided by R, where delta P is excess pressure, gamma is equal to surface tension and R is equal to radius. And that they are asked liquid drop model. So step 2, rearrange for gamma. We have to find surface tension. So we have to rearrange the formula. So gamma is equal to delta P into R divided by 2. Now we'll substitute values. Gamma is equal to delta P into R divided by 2. So delta P is equal to 1.5 into 10 to the power 5 into R is equal to 1 into 10 to the power minus 6. So divided by 2. Here gamma is equal to 1.5 into 10 to the power minus 1 divided by 2. So after reducing, gamma is equal to 0.15 by 2. Finally, that surface tension will be equal to 0.075 Newton per meter. Step 4. We will convert to meter Newton per meter. 1 Newton per meter is equal to 1000 meter Newton per meter. So gamma is equal to 0.075 multiplied by 1000. So gamma is equal to 75 meter Newton per meter. So final answer will be 75 meter Newton per meter. So option 4 is the correct one. If this video helped you, please like and share. If you want more content like this, please subscribe to my channel. Thank you. Have a good day.